Great. Well, good morning, everyone. I'm glad to be here today. My name is Dan Pitt. I'm with MEF, the former Metro Ethernet Forum. Now it's just the MEF Forum. And I've been engaged with OCP since July 7th of 2011. First time I got an email from John Knievy. And I went to my first workshop in 2013 and been coming to all the summits since then. But this is the first time that MEF has actually presented at the OCP Summit. I joined MEF a year ago, January. I was certainly here last year and all the prior years. This is our first chance to present, and we're very excited to do that. And I want to talk about what we're doing and how it relates to OCP. We talk about Lifecycle Service Orchestration and the APIs and how that actually really enables the adoption of OCP. Whoa. Why is... well, that's part of it. Want to go?
Capital presentation. Can we back out of it? Yeah, there you go.
Yeah. I mean, you want to go to mirror displays or something?
Would you be able to do that way?
Oh, yeah, it's easy. We do, huh?
But is it your presentation or is it your...
I don't know. Let's see what happens when I go to presentation to slide view. Oops.
You have it underneath.
So let me go back to that. Mirror displays, how's that? Okay, now let me just go here. Whoops. Go here. Yeah, this looks better.
We have a beautiful car again.
Oh, wait. Well, that's odd. Let me try. Whoa.
Could we make this complete and then just move it over? Maybe this, can we do it that way? Just grab and push it over?
Well, I can move it around, but it's not going there.
So once you make it large, then you can push it over.
Yeah, I should have done that. So shouldn't I be mirroring the displays?
Well, it could be in presentation mode. If it's not working, you could go into mirror.
So it says mirror displays.
So bring it back up, and we'll just shove it over. It comes up on your laptop. There you go, sir. There you go.
Well, should I try to go to the next slide? Oh God, I just moved the cursor. And I'm back out of display mode.
Well, let's try that one more time and make this big. I guess you can make that by mirroring, or just make this large and then we'll shift it over. Push it over.
I can also go to a PDF of it. You think that'll help? You think it's PowerPoint that's a problem? All right. Gosh, this is weird. I don't even see the PowerPoint. Okay, I'm going to exit PowerPoint. Whoa. No, I'm not. Okay. Sorry. Okay, so here it is here. Now, if you want to see what happens? Oh, there's slideshow, there's presenter view. See, look at this, this is all goofy. All right, I'm gonna go to the PDF.
Your desktop is probably extended.
Well, I just have multiple desktops here. You hide that, that's. So let me go to the PDF. Try doing from that. Okay, is this visible okay? Okay, we're going to go with this. sorry for that. I don't know. I mean, we're only computer scientists here, so we can't figure this stuff out. Anyway, so I'll go through this more quickly. I really want to talk about why I'm here, why MEF cares about OCP, and why I think we represent an opportunity for OCP. I'll talk about our language and our lingo like MEF 3.0 and LSO, and in particular how we have opened up to a much broader community that will involve OCP. So we are a nonprofit tech trade association, formerly sort of a standards body, member dues contribution, and we're really focused around the telecom industry. So we have 200 and some members, of which 60% are the telecom operators from every continent except Antarctica, and a lot of vendors that support them. And our goal really is to help them modernize their businesses and to figure out how to do that with the new technologies and what their contributions are going to be. So they make money by providing services of all kinds, from basic connectivity services to much higher value-added services. But the services such as carrier Ethernet, which is how MEF made its fortune, is a static service. We want these services to be agile, orchestrated, and assured because that's what the customer needs are and the workloads are reflecting. We do this through service definitions, the APIs I'll discuss today, certification process I won't talk about, and the expanded community. So the picture of a carrier's world these days is much more complex than it used to be. I've just put in sort of everything but the kitchen sink here. They've got different kinds of customers, from consumers to enterprises, all kinds of new technologies, fixed and mobile, whether it's 5G or subsea cable or carrier Ethernet or something else. Much more of a demand for responsive services. We're seeing internet used as a connectivity means for low-value applications, and then reserved and high-value services for those applications. A lot of connectivity needs to the cloud operators, like Google, Azure, and so on, Amazon Web Services, and then all kinds of ways of providing those services, whether it's direct connect, whether it's with SD-WAN, or whether it's with something else. The customers want these things to be ordered on demand and paid for only when used, so they have these portals into which they will insert their commands either by humans or increasingly in an automated fashion. We've got edge computing, we have analytics now, helping to complete the loop between what the network state is and what the desired business objective of the network is. So you can just see examples of a lot of these things here. And this is just within the domain of one operator. I'll show a picture with multiple operators. And what we do is really find ways to connect multiple operators together to offer global end-to-end services. So the principles that we're trying to follow in modernizing these businesses of the telcos are these. We want them to be able to adopt SDN, NFV, cloud, both centralized and at the edge. Disaggregation as via OCP and open source. I spent about 6 years just sort of deep into the world of SDN. And that's when I started understanding how you might implement it in different ways, including in a bare metal or white box way with OCP. So the principle for the MEF, the opportunity for the MEF community is to include OCP as an implementation option in whatever part of the network they wish. And for the OCP community to understand there's a large opportunity in the telco world, but it's made easier through the abstractions and the interfaces that we have defined and that are being adopted across the industry. We also assume that they don't have the liberty of doing only greenfield, so it's a brownfield world. And we try to develop what we call healthy ecosystems that have a prominent role for the vendors. Because many in the telecom world don't yet have the staff or the skills to do a lot of this themselves, and there's a lot of integration work required to take, say, a big open source project, hardware or software, and integrate it into a service that they can bet their business on. So that's why we work closely with all of those, and we really strive not to publish a certain number of beautiful specs, but to see the success in the business of our members and their industry. So we just introduced last fall something called MEF 3.0, which sort of incorporates everything we do under 4 pillars. I won't go into detail of most of them. Services, APIs, certification, and community. And the services used to be only one service, carrier Ethernet of 5 varieties. Now it's all of these things, layer 1, layer 3, and some layer 4 to 7 advanced services. The certification used to be you'd send a box in and get certified, and you'd certify a static service. Now it's an agile certification process. And our community, we used to be like most others in sort of a silo of our own. We did our own thing, but we cannot survive that way, and almost no one can. So we've really expanded our community outreach and have many more engagements with other parts of the ecosystem. And the LSO APIs I will discuss in greater detail. So what is LSO itself? It's a framework of abstractions. We have defined a number of components. I will show those on a slide. They're defined by their function. They're separated by reference points. Across these reference points, or between them, we have abstraction. These are abstraction boundaries. We have APIs. Now, the term API is very loosely used by me. It's an application programming interface, but some of these are east-west protocols, really, and some of the APIs are not within a server, but they're between a control plane and a forwarding plane, or an orchestration plane and a control plane. And I'll show what these are. But our purpose in doing this is to enable the service providers to compose their own services in their own domain and concatenate them with other operators. But the most important thing is they have their choice of how they do this. Do they buy bundled products? Are they closed? Are they proprietary? Are they open but not open source? Are they truly open source? Are they integrated? Are they separated? Are they based on bare metal? Lots of choices in lots of different parts of the network. And to foster a supplier ecosystem that really works with existing and new suppliers as they meet the needs of their customers. We were sort of a standards development organization for many years, and so we have these formalities, which we still have. We define APIs pretty strictly. We have information models. This is a growing part of our portfolio. From those, we derive data models, which are code that runs. And we have interface profile specifications, or IPSs. These are the formal standards we define. We formally define services, and then we certify services, products, and skills. But we've added these informalities. We have hackathons now a couple of times a year. We have a developer community, largely academic-based, that's helping us put together some of these things. And they develop with us and our members SDKs for the APIs, which we now deliver before we finalize the interface profile specifications. And if you think this hasn't caused a little controversy, you're mistaken. It's caused a lot of controversy. When do we issue an IPS? What can we say about the SDK as we issue it? It's not supposed to reflect the final IPS, or it wouldn't be very useful. It's used to develop the final IPS. We have really a huge facility called MEFnet with a lot of computational power and a lot of VMs and a lot of ways to experiment with and try out configurations and some of the new technologies and protocols. And then we and our members build example implementations just to see that it works, and then reference implementations that you can hopefully do more with. So with these APIs and the SDKs, they're based on a framework called MEF 55. I'll show a slide of that. But then we release them as SDKs in experimental SDKs or published states as they get mature. And we're on a 3 to 6 month sprint cycle of these, which is really new for us. but it really matches how you do software. And we define epics and user stories. We implement the data models after the information models on MEFnet. And then we share these with other SDOs, open source projects, and we feed them back into our spec development. So this was supposed to be a build slide on PowerPoint, but the left vertical slice is the customer, and then the center and the right are two operators that are concatenated to offer an end-to-end service. And I want to highlight the Sonata interface, which is sort of the upper right. This is business to business. This is really for ordering a service, determining that it's available at a certain address, and agreeing to find a way to pay for it. The left side from the customer portal, it's sort of the same thing, but not quite as technical. The one below it, east-west, called interlude on the right, is really at the operational level. So you might almost think that Sonata reflects the BSS and the interlude reflects the OSS. How is the service running? What is the state of the network? This is dynamic as the service is going, whereas Sonata is really to instantiate it and then take it down. Those are the really important ones, and I'll show an example of those. But they enable operators, to, regardless of how they do what's inside their own world, concatenate with another operator to offer an end-to-end service. Then on the vertical side, we have Legato, Presto, and Adagio. And once you have this business application, knows what you want to do, you talk to the service orchestrator, and there are examples of that I'll show. Can you activate this? And here's the performance metrics. And then from service down to infrastructure control and management, that's Presto. That's like to an SDN controller, for example, which then talks to the switches that do it. So we have these defined in prose, then we put them in code. We've made most progress on Presto and a Sonata right now, and I'll show an example of how Sonata has come to a very interesting application. Our community has expanded, as I mentioned sort of earlier, and that's now starting to include OCP. We do spend a lot of time on information models, and we have our MEF core model. And these are really important. We've been working for several years with some of these other operators and organizations to try to come up with some kind of a consolidated, agreed information model or framework, or at least a federated approach to modeling. And in fact, we're hosting a meeting this Sunday in Los Angeles as part of the Open Networking Summit with these players involved to try to come to some agreement on where are we going to use Tosca, where will we use JSON or something else, so that we really can work together and move this whole thing forward. But we're model driven in what we do, and that's really the only way to allow the technology to evolve rapidly through the abstraction of the models. We have a number of implementation projects. The ones that I think about when I'm here at OCP are closed loop control, service telemetry, and kind of real-time media, I would guess. And I've talked to some of the people here at the show about some of these. So this gives us an experience in actually building systems that work. They teach us something. They feed back to the other work we do in defining the APIs and the service definitions. And they enable us to integrate with some of the open source projects and to feed some of what we do into those projects. We've upstreamed a number of code contributions to some of these projects. So this is all new for us to get our hands really dirty here. But with things that are software-based, you can afford to mess around before you finalize something. So here's a more complex picture of how you might view LSO with SDN and NFV components using open source projects and OCP, which you see down in the bottom center. So we have two operators that are connected via Sonata and Interlude, and they're implementing their orchestration in different ways. One uses ONAP, one uses OSM. We've got different SDN controllers there. We have virtual switches and physical network functions and VNFs both. And these are where you can see OCP being adopted in the cloud, in the edge cloud, and at the edge. And the way that the telcos businesses are evolving is as they extract control out of the devices themselves, more and more this control just lives in a data center environment somewhere. Now it could be centralized, it could be distributed, it will probably be both. As they adopt more and more cloud technologies for running their control planes and management planes, those technologies really fit the OCP model very closely. And that's why we're here. So just want to offer one example of a end-to-end fabric based on OCP that was demonstrated in November with two POCs, one between France and the US, in which both operators used ONAP and they instantiated the service using Sonata and monitored it using Interlude. The other was between the US and the UK and Ireland, actually, in which the US operator used ONAP and the UK operator did not use ONAP. It was a vendor-based orchestration solution, but they still were able to effect the end-to-end solution, including a little sidetrack over to an AWS data center in the Republic of Ireland. But this showed that they could offer an end-to-end service with an operator in another geography where they did not have a footprint, and that other operator could use whatever orchestration system and control system they wanted. This gives them the freedom, really, to incorporate in their own network whichever suits them best. So they can implement things how they wish without worrying about how somebody else is doing it, so long as they meet at a known interface point. So that's why we're working closely with ONAP and other projects to help them build in these common APIs and interfaces. So we offer and try to offer the operators a certain number of degrees of freedom where they have to have choice because their businesses are all different. So where they can do greenfield, great. A lot of it is brownfield, so we want to help them start with that and get there from here. We're no longer just carrier Ethernet, and they have lots of transport technologies of high interest in different parts of the network, even at the same time. And you certainly think about this when you consider the edge access increasingly becoming available via 5G. The use of cloud will only continue to expand, and whether it's a telco cloud that's unique for them or a public cloud, which some services are already migrating to, an edge cloud, some things in a premises data center, and stuff that's still out in the network, because that's where you have to do certain things. It shouldn't matter to them. Let them make that choice based on the application, based on the revenue model, and based on the technology they want to adopt. We want them to try open source where it makes sense, or just open interfaces on closed source, or a purely proprietary solution where it makes sense, where they can get the support they need, where it's most compatible with the systems they have in place today. And finally, whether they implement a function in hardware or software, whether they are integrated, whether they start with bare metal, whether they use OCP or a TIP solution, that's their choice, and we want to give them these choices. We believe that these choices are enabled by the abstractions we define in LSO that isolate these different components via their reference points. So my conclusion is that the telco industry is going through a major transformation, as are most enterprises. And this is going to happen whether they like it or not. So they have these new technologies and architectures, both on the networking side and the computing side. And I contend that since the advent of SDN, networking is increasingly becoming a part of computing. They want their services and their applications to run invariant over the technology choices, because they may run over many technology choices in the same service instance. We are finally seeing the breakdown of the monolithic OSS and BSS into SDN, NFV, and OCP components. This will only continue. The supply chain is changing, their own skills are changing, their processes are changing. We've also noticed that this transformation is affecting us in MEF as an organization itself and how we work with our members to provide them with the solutions they need. So we no longer issue only specifications, although we still issue specifications because they are important. But you can't just be an old-fashioned SDO anymore. So SDO and standards and open source are really working hand in hand, and we are doing this through the SDKs, the POCs, the information models, and the experience we gain with MEFnet. We have and are cultivating a global ecosystem of partner companies, organizations, and .orgs, of which OCP is a good example. And we are experiencing a new pace ourselves, a new cadence of results and things that we issue. We have the tension inside of this transformation from standards to open source, but we're learning to act with a new agility as we are expecting our members to do. So I believe that the LSO framework and the thrust that we're taking opens many opportunities to incorporate OCP in the world of the telcos, especially as they move to cloud and edge computing. And thank you for your attention. Sorry for the glitch at the beginning. I'll be happy to take questions afterwards. Thank you.